Good morning and welcome to Varmus Chem. This video is going to be on solving molarity problems. So this is the second video on molarity. I'm hoping you guys, this helps solve molarity problems. This is not necessarily talking a whole lot about the concept, but it requires you to understand molarity to kind of be able to tackle these types of problems. So they're not very simple, especially if this is the first time, it's your first brush with chemistry, but it's terribly important to solving these problems when you work in a lab, specifically if you're working in either biology, molecular biology, chemistry lab. These become very routine, but terribly important to get these right. So let's get started, and hopefully by the end of it you'll be an expert. So I have a very specific way of setting these up, and I just want to get started right away. So molarity assumes, whenever you hear the concept, just remember that usually there may be a powder involved. So if you're going from a dry powder into a liquid, okay, you're usually and oftentimes asked to calculate a specific molarity. So that's the first problem we're going to solve. Again, you're trying to calculate the specific molarity from a powder. Okay, now how I go about doing this, it's very specific. So give me a synonym for taxi. Okay, it's not jitney, although jitney is a great Scrabble word. The word I'm looking for is cab. So I'm going to write that out. So that's cab. Now, in cab, the C stands for molarity. The A stands for moles. And the B stands for liters. So it's very important, if you're given milliliters, you've got to actually convert it into liters. So you've got to remember that conversion factor. I'm also assuming you know how to calculate molar mass or formula weight, because you're going to need that to be able to convert from grams to moles. So the moles, you're going to at some point need to remember how to convert from moles to grams. That is not the subject of this video, and so I'm assuming you remember how to do this. The liters is a conversion if you have milliliters. So if you're given liters, you're all set. But if in milliliters, you've got to convert, or any other unit for that matter, it could be in microliters, you have got to convert 2 liters for this to work. So if in milliliters, you must convert to liters. Okay, and molarity, of course, is an uppercase M, and that is usually given to you. So the formula is C is equal to A divided by B. Now, I use the cab analogy because if you are looking for moles, just cover that up, and it's C multiplied by B. If you're looking for molarity, it's moles divided by liters. If you're looking for liters, it is moles multiplied, it's moles divided by molarity. So again, moles divided by molarity will give you liters. If you cover up A, which is moles, you multiply C times B. So that's molarity multiplied by liters. You're looking for moles, in that case A. Okay, so let's solve a problem using this. Again, I call this the cab strategy, CAB. If you've ever done density problems, it's analogous to the DMV problem, the way the DMV is set up in a triangle. Again, you cover whatever it is you're looking for. Let me get you the first problem. Okay, so 34 grams of sodium chloride, and we're going to dissolve that, make a solution that is 100 112 milliliters. Okay, so you're making up 112 milliliters of basically brine, salt water. Okay, and in that 112 milliliters, you dump 34 grams. So keep in mind, the 112 is the final volume of the solution. That's very important to remember. You're not adding 112 milliliters of water in this case. You're just making sure you make up a total of 112. So it'll be the amount of water you actually add is going to be less than the 112. Okay, so here goes. So that's the question. So 34 grams. Okay, we don't have anything in grams in the CAB formula. So, but we can convert 34 grams to moles. Okay, that's important. So 1 mole is equal to 58 grams sodium chloride. And how do we know this? Because the formula weight of sodium chloride is 58 grams. Okay, so that's the molar mass. So sodium chloride is 58 grams. That's why I've written 1 mole is equal to 58 grams. We are given 34 grams. So what are we looking to do? Okay, so 34 grams, so it's given multiplied by want over know. We are given 34 grams. We're multiplying by that by a conversion factor where we need to have grams on the bottom. So we're going to put 58 grams sodium chloride on the bottom. And that's a Cl, by the way. And up here we've got 1 mole. So when we divide 34 by 58, that gives you 0.59 moles. So this is 0.59 moles. Okay? That is your A now. Okay, so that's A. Okay, now let's take a look at how much we wanted to make. We need to make, or we are making 112 milliliters is equal to 0.112 liters. Okay, this is going to serve as B. So molarity is equal to A over B. So this is equal to 0.59 moles divided by 0.112 liters. And that gives us 5.23 molar sodium chloride. Now again, keep in mind, the moment you see NaCl, and I know my Cl looks like a D, but the moment you see this, and you see this capital M, uppercase M, you need to be very clear that this is a liquid. This is in a bottle, it's usually in a flask or something, but it's definitely a liquid. It is no longer a powder. You have dumped in 34 grams of sodium chloride to make yourself 5.23 molar sodium chloride. That's the first one. Let's get to another problem with a slight twist, but same exact concept. You're going to use CAB. The second problem we're going to do actually flips the previous question on its head. So this time around, I want you to tell me how many grams of sodium chloride are there in a 53 milliliter solution. So you've got 53 mils of a salt solution. That is 2.5 molar. Okay, so you're given a 2.5 molar solution, and you have 53 milliliters of it. The question is, how much salt did you dump in here? So the last time around, you were given the amount of salt. You were looking to calculate the molarity. This time around, you're given the molarity, and you're given how much of it you made up. So the question is, how much salt did somebody actually put in there, or did you put in there? So let's solve it. So the molarity is represented by C. So again, C is equal to 2.5 molar. So that's all set. B is liters, but the question is given to us in milliliters. It says 53 milliliters. So you have to convert milliliters to liters for this to work. So let's just do that. So B is equal to 53 milliliters. 53 milliliters gets converted in the following way. So 53 mils multiplied by 1,000 milliliters on in the denominator and divided on top on the numerator, you've got 1 liter. So milliliters cancel out and you end up with 0.053 liters. So B is 0.053 liters. So in order to solve for A, okay, which is moles, we need to multiply C times B, and C multiplied by B is equal to 2.5 molar multiplied by 0.053 liters, and the answer is in moles, and that is 0.13 moles. It's really important to remember that in order to get to grams, you actually have to make the journey by first converting to moles and then from moles to grams. So we've got 0.13 moles, which is A. Now, we know that the molar mass of salt, of sodium chloride, is 58 grams. That is a no. Therefore, 1 mole over 58 grams, or 58 grams over 1 mole. And we're going to pick one of these conversion factors. So we have the moles. We have 0.13 moles given to us. So the given at this point is 0.13 moles. So this is the last part of the problem we're trying to solve to calculate the number of moles. So given 0.13 moles, we're going to multiply this by this conversion factor. So 58 grams divided by 1 mole. Mole cancels out. So it's 0.13 multiplied by 58 grams, and this is equal to 7.69 grams. So what we're saying is that if you had 53 milliliters made up of a 2.5 molar sodium chloride solution, in here, you put in 7.69 grams of NaCl. So this is the second type of problem. The first one was where you're given the grams and you're trying to figure out the molarity given how much you're going to make. In this problem right here, this is the second problem, you're actually looking to figure out how many grams of salt were dumped into the solution to come up with the molarity that you wanted. And we'll solve the last type of problem in this video next. So glad you've hung in there. So this is the third type of problem and the last, I promise, at least for this video. A 2.75, so 2.75 molar salt solution contains 8.5 grams of sodium chloride. How many milliliters or volume of sodium chloride solution did you make? Okay, again, fairly straightforward. Let's just make sure we can identify the different components, okay? But using the CAB formula makes everything a lot easier. So we know that the molarity that we're given is 2.75 molar, okay? Remember, that's the molarity. Okay, we are given the number of grams. We are given 8.5 grams of sodium chloride. That's how much was dumped in here. So I want to draw this out so you can see it. Okay, so you've got this little container. It could be a biggish container. It's got a certain amount of liquid in there, and you know that its concentration is 2.75 molar, and you are told that 8.5 grams of sodium chloride was dumped into it. So these are the two facts you know. This is C, and this is going to become A right here. Okay, how are we going to do that? So 8.5 grams of sodium chloride, keep in mind this is not in moles, must be converted to moles. Okay, so just remember, it's absolutely critical that you not forget the earlier stuff because it's all tied in. So here you're going from grams to moles. Okay, so we're given 8.5 grams. Okay, so what we know is that 1 mole is equal to 58 grams NaCl. So our conversion factor is going to be 1 mole over 58 grams NaCl. Okay, I'm hoping you guys jog some memories here. And you're given 8.5 grams. So 8.5 grams is your given. And you're going to multiply that by the conversion factor. So 1 mole over 58 grams NaCl. Okay, so again, the grams NaCl grams cancel out. So this is equal to 0.15 moles NaCl. Okay, so now this is actually A because you have it in the right units, 0.15 moles. So now we're solving for B. So again, you cover what you want. So it's A divided by C. So A divided by C is equal to B. So A is, let's see, 0.15 moles divided by, the molarity was 2.75 molar. And this is going to tell us how many liters. So we get 0.054 liters. To convert liters to milliliters, again, guys, we just circle back. You've got to remember these conversions. So 1 liter is 1,000 milliliters. So 1 liter, so 1,000 milliliters is equal to 1 liter. Conversion factor here would be 1,000 mils over 1 liter. We'll call this conversion factor A. We're going to use that. So 0.054 liters multiplied by 1,000 milliliters divided by 1 liter, because we just moved that down here, is equal to 54 milliliters. So we've looked at 3 different types of problems. One requires C, one requires A, and then one requires B. Okay, so always try, just remember this little mnemonic, I guess, CAB. It's very similar to the DMV paradigm, and you should be able to solve many of these problems, and I'll do some more videos on this. But again, I hope this helps. Just remember, if you like it, knock that like button, and see you in the next video. And just remember, I'm really proud of you for hanging in there, for remembering this good stuff, and have a fantastic rest of your day. Just remember, if it ain't chemistry, let's just stamp collecting. We'll see you later. Bye.